Welcome to today's Explainer. I am absolutely pumped for our topic today because we're looking at a literal David versus Goliath scenario in the tech world. We are going to explore how a completely unassuming two-in-one tablet is just casually matching the raw power of those bulky, power-hungry home lab servers when it comes to local AI tasks. Seriously, this isn't some theoretical concept. This is happening right now, completely locally, on a device you could be using to watch YouTube in bed. It's an incredible look at the bleeding edge of portable computing. Here's a quick look at our roadmap today. First, the ultimate AI tablet. Second, 128GB unified memory synergy. Third, Lemonade's smart model router. Fourth, benchmarking the 120B beast. And finally, unlocking portable agentic coding. Let's jump right in.
All right, starting us off with Section 1, the ultimate AI tablet.
So we aren't talking about your standard everyday consumption tablet here. The device we're looking at is the ASUS ROG Flow Z13, but specifically it's the Ludens Special Edition, which was actually created in collaboration with Kojima Productions, the legendary video game studio. The whole sci-fi, futuristic gaming aesthetic is so spot on here. It just feels incredibly fitting when your primary use case is casually running massive, heavy, large language models from the comfort of your couch. But here's the thing. Just because you have the power to run a massive, heavy model doesn't mean you actually want to use it for every single task. As the source material points out, it's a little like the adage about everything being a nail if all you have is a hammer. If you're just asking a simple trivia question, spinning up a monstrous heavy-duty AI is terribly inefficient. To truly make a tablet an AI powerhouse, you need the right hardware paired with really intelligent scaling.
Moving right along to Section 2, 128GB unified memory synergy.
128. That is the magic number today. This tablet features the AMD Ryzen AI Max plus 395 APU, and it boasts a mind-bending 128 gigabytes of unified memory. Now, for the hardware enthusiasts out there, you already know how rare and frankly overpowered that is for a portable form factor. It's literally the exact same APU and memory configuration you'd find in the high-end mini PCs that normally power dedicated Proxmox servers and massive home labs. The absolutely crucial point here is how you utilize that massive memory pool. Using AMD's Adrenalin software, you can actually carve out a massive 96 gigabyte slice of that memory specifically for the Radeon 8060S integrated GPU. That leaves 32 gigabytes just for standard system operations. By dedicating 96 gigs entirely to the iGPU, you instantly transform a standard 2-in-1 into a memory-rich LLM beast, totally capable of running the exact same lineup of models as a dedicated desktop. That brings us to Section 3, Lemonade's smart model router. Okay, let's dive into how this actually works in practice. To solve that whole hammer and nail problem we talked about earlier, the source uses an application called Lemonade to set up a smart model router. Because there's just so much RAM available, Lemonade can keep 5 distinct model tiers sitting simultaneously in memory. You've got a tiny 2 billion parameter model for basic readings, a daily 9 billion one for everyday writing, a 30 billion coder model, and a massive 120 billion parameter heavy model for the really hard reasoning tasks. And on top of all that, there's a lightweight 0.8 billion parameter model acting as the router brain. Combined, that is 85 gigabytes of model weights sitting completely ready in memory, just waiting to feed the iGPU. It all builds into this beautiful automated workflow where the router acts as a Lemonade policy collection. To any application you're using, it just looks like a standard OpenAI-compatible endpoint. Step 1, you send a prompt. Step 2, that tiny 0.8B router brain analyzes your text and judges the difficulty. Then, Step 3, it automatically fires your request over to the most appropriate model tier. You never have to manually pick a model again. The system just intuitively knows whether to give you the lightweight quick hitter or the heavy reasoning beast. Though getting that router brain to work perfectly did come with a pretty hilarious hiccup. The source ran into what we'll call the hybrid thinking trap. The 0.8 billion parameter model they used for judging difficulty is actually a hybrid thinking model. Well, initially, the user forgot to turn off the thinking feature. So when they sent a super simple prompt like, "Hey, what's up?" the router brain started aggressively arguing with itself over how to classify a basic greeting. And it actually ran out of tokens before it could even route the prompt to the easy tier. A quick prompt fix later, though, and it was back to flawlessly sticking to its rule-based routing.
Now for the really fun stuff. Section 4, benchmarking the 120B beast.
This perfectly proves why this setup is such a big deal. When the router decides a question needs maximum grunt, or if you just manually force it to use the heavy tier, it taps into a 120 billion parameter model.
That is a massive 56 GB file. But because of this tablet's incredible unified architecture, it loads into memory in just 27.6 seconds. And what's even more impressive, the time to first token, which is how long it takes to actually start answering you, is a blistering 0.86 seconds. Less than 1 second to get a desktop-class response from a massive AI, all because those 85 gigabytes of weights are always sitting ready. To really put into perspective why this specific unified memory setup is absolutely make or break, check out this contrast. At one point, the source accidentally misconfigured the router, which forced the 120B model to run a CPU-only benchmark. Despite using the exact same RAM pool, the same hardware, and the same file, it crawled at an agonizing 0.44 tokens per second. But when properly routed to the iGPU, it churned out text at an incredible 52.03 tokens per second. That is over 100 times slower if the hardware synergy isn't locked in perfectly.
And finally, Section 5, unlocking portable agentic coding.
So an autonomous agent is notoriously tricky to run locally because it uses every single token it can get its hands on to reason about even the simplest things. It constantly needs to understand entire code bases and its own tool capabilities. So we face a real technical hurdle here. What happens when an AI coding agent needs to read over 13,000 tokens at once, just to say hello? The bottleneck here is the context window. The coding agent being used, called Crush, sends its full tool schema in every single message. So literally just saying hi sent exactly 13,072 tokens straight to Lemonade. The catch was that Lemonade launched every model with a default context window of only 4,096 tokens. But hey, remember we have 128 gigabytes of RAM to play with? The software fix was incredibly easy. The users simply went in and changed Lemonade's default setting to 32,768 tokens. The tablet's massive memory handled this huge context expansion without even breaking a sweat. Which leads us to this triumphant final benchmark. With the context window fixed, the router flawlessly directs the Crush agent's massive prompts over to the 30 billion parameter coder model. And even while juggling a nearly 14,000 token context, this ASUS tablet is generating code at 52.34 tokens per second. You are getting incredibly fast agentic coding capabilities completely locally on a 2-in-1 device. It's a total game changer, which really leaves us with one massive final thought. If a device you can hold in your hands to watch movies in bed can leverage 128 gigabytes of unified memory to seamlessly route and run 85 gigabytes of distinct AI weights locally, what does this mean for the future of bulky traditional home lab servers? As edge computing becomes this unimaginably powerful, it might seriously be time to rethink what a powerhouse actually looks like. Thanks so much for joining me on this explainer, and keep questioning the limits of your tech.